So let's look at how we could write Cengage style test questions with variables. And we'll first look at using simple algorithms in our work. And let's go on to Cengage OWL 2, OWL version 2. And when you click on your course, this is the page that comes up. We're creating things in new assignments or old assignments. So we're going to click on the assignment tab. And then if you look down here, kind of hard to find sometimes, but you get used to it. Self-authored questions. So these are questions that you put together yourself. So if we click on that, we come up here as all the ones that I've done before. And let's create a new question. And it's a little slow, so here we go. Now we're going to put this in algorithm questions in that folder, which I've created before. And this is going to be a numeric. We're going to do a Boyle's Law problem. Actually, let's do something first. Let's go to one that I've already done so we can look at it and kind of get the lay of the land here. So we called that Gas Law 1. And if you're familiar with Boyle's Law, you realize that if you have a gas in a syringe and it's got a certain pressure and you increase the pressure, well, its volume is going to decrease. So that's where we get the Boyle's Law. If the temperature doesn't change, pressure 1 times volume 1 is equal to pressure 2 times volume 2. That is always going to be a constant. So we show an ideal gas in a sealed container so it doesn't leak with a volume of 32.0 milliliters at room temperature, and we measure the pressure. It's 115.0 kilopascals. We then increase the pressure to 140.2 kilopascals, but we don't change the temperature. And the ask is, what would the new volume be? And we give Boyle's Law here just to make things a little easier. So what we do, I just opened up a calculator, and to create the answer, I took 32 and I multiplied it by 115, and we divided it by 140.2, and we got, push enter, with 3 digits, because there's 3 digits in the volume originally, 26.2. And so I simply put that into this field, which is the answer field, and you can see it right here, 26.2. And so if we take a look at this question under the preview, right here is where you preview, we see the question comes up, and there you go. And that would be a fine quiz or test question. But there's just one set of data input. There can only be one answer. So if Johnny's sitting here and he's conscientiously doing the problem and puts in the answers and puts in 26.2, well, the guy or gal next to him can just kind of look over and see the answer is 26.2, and they don't get the benefit of answering the question. So maybe you'd kind of like to change these numbers here, vary them, particularly in a way that you can't predict. And that's exactly what Cengage allows you to do by using its variable functions. So what we're going to do is we are going to repeat this question, the format of the question. So I'll just push Control C here, and we're going to go back over here, and we are going to create in our algorithm folder another, now this is a fill-in-the-blank numeric question. And we're going to call this gas law 2. Well, let's call it 1C, since we've already got a 1B. And so we get the blank field. I can just paint that out and push Control V, and I've copied the question. But I'd like these numbers to change a bit, maybe have 15 or 20 different V1s and 15 or 20 V2s and 15 or 20 pressure 2s. And that'll generate, gosh, you figure out the number of variations on that. It will be very difficult for somebody to just look on and cheat. So let's make it happen. And how do we do that? Well, we can click on the algorithm button, and we can generate new variables. So we want a variable for the volume 1 and the pressure 1 and the pressure 2. So let's do them all. So a new variable, we're going to call this volume 1. Now notice it gives you a choice. We don't want an integer. This is a real number. This is a number with a decimal tenth. And it gives you a general template here. So when we click on Create Algorithm, we get something that looks like this. In fact, it always looks like this when we choose a real variable, but that's not what we want. If you look over here, we had 32. Now, if we want to stay around 32, let's start. Here's your start volume. So it could choose anything from, say, 31.8. And how far do we want to go up? Let's go up to 41.8. And let's go ahead and say 0.2 is the increment. So it can choose 31.8, 32.0, 32.2 by 0.2, all the way up to 41.8. All right, we're going to save this algorithm. And in fact, we are going to paint this out and insert volume 1 right there. All right. Now let's create a new variable. And we're going to call that pressure 1. P-R-E-S-S. Oops. Need to learn how to type. Pressure 1. We're going to call it a real number. Create it. Now we're at 115. Let's go from 110 to 120. Make it a little easier on us. Excuse me. 110.0, 120.0, and let's vary it by halves, 0.5. We save the algorithm, and let's put it right there, and we insert pressure 1. Finally, we're going to create, well, this is not actually finally, we're going to create pressure 2. We're going to call it a real number. Gives us our little template there when we open up. We're going to click on this, and we are going to have a start position. Let's say 138.0 and go up to 148.0, and let's do that by 0.2. So it can be 138.0, 138.2, all the way up to 148.0. So save that, and let's insert that where we want this second pressure. There. Now we have to do something. All right. It's actually fairly easy. If we're solving for the new volume, V2, a little simple math tells us that it's P1 times V1 divided by P2. Oh, okay. So let's create a new variable, but this is not going to be a real number. Well, it'll be a real number ultimately when we plug numbers in. This is going to be a formula. So we're going to create that, and we're going to call that volume2, VOL2. So we create the algorithm, and oh, there's nothing there. Huh. Well, what we're going to do is we're going to type in our expression here, and we said that's volume 1 times pressure 1 divided by pressure 2. Got to be careful and put exactly the right name in. We're going to save that. Now, where are we going to insert it? Oh, we're going to insert it down here, aren't we? Oh, okay. Well, let's get rid of that because we don't want that. And we're going to insert there. Oops. Not there. Get rid of that and insert it there. Volume 2. Okay, and it's happy. Good. So we're going to close this out, and let's take a look at our question. Can it be that easy? Yeah, it actually can. So we preview the question, and we look at it. Oh, it says volume 2. Didn't do that right. Let's go back. And let's go to the question. And save that. And in fact, I'm going to close out. There's my algorithms. There we are. Let's see. Insert. Let's see what that does. We preview. No, that's not working. There we go. Okay. Let's get rid of that. Let's save it and preview. And we see, behold, everything's fine. Right number of sig digs in all cases. But we don't have the right sig digs here. Need to fix that. We said we wanted 3 sig digs. Now, how do we do that? How do we do that? Well, we actually can double-click on this. If we double-click on the painted out variable name, and we go up here, these are the various properties of the number, and we wanted how many sig digs? We wanted 3, didn't we? Okay, so let's save that, and let's preview it, and we've got it. We've got it just the way we wanted. However, we want to do one more thing here in the question. Save the changes, and we want right here milliliters. Let's save it, preview it, and our question is done in less than 15 minutes. And that's the way you do this with algorithms. Let me show you one neat thing. If we click on preview again, we get no new numbers. And again, we get new numbers. Now I saw once that we had 2 sig digs in this initial volume, so I might have to go back and specify 3 sig digs with the properties. But this gives you a good idea of how to get started on writing your own questions and be able to give each student a different set of numbers.